You ready for this one? Let's try it. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals ln x over 2 plus 3 and 2 plus 1/2 x about the line y equals 1. Whoa, what? Okay. This is the region we're dealing with. Let's highlight it. It's this little guy right here. And I need to find my intervals. I'm definitely going to need to find that because in just a minute I'm going to be like, oh, look at my little interval. And I've got the integral symbol with the intervals and I don't even know where it starts and ends. I mean, this one was easy. It was -1 to 1. You could look at the graph and tell, but really you could just set this equal to this and solve it and you would have found that. It's going to give you the same thing. So basically I have to solve this in order to figure out what these x values are, or y values even, which we'll get to in just a minute on number 5. So let us proceed by just figuring out what we're dealing with. If I'm going to rotate around the line y equals 1, then I'm rotating around this line. It crosses the y-axis at 1. So, and as I do, I know that I have the integral. Let's write it in green. I have the integral from somewhere to somewhere of curve minus line. You can kind of look at it that way. And then you say, okay, which function is which? Well, there's your curve and there's your line. Now, I don't want to just write this minus that. That's not going to jive with me. That's not going to work too well. And also I need to keep in mind that I'm going to be rotating, which creates a circular shape. So pi r squared in this circumstance. So blah, 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 dx. Okay, let's figure out first of all what these two values are, and that's going to come in handy with a calculator. So let's do it. There, type that. Natural log of x, and then we're going to divide that by 2, and then we're going to add 3, and then the other one is 2 plus 1/2 x. All right, just a standard window. When we do the standard window, we'll be able to see the x-intercepts. We'll be able to see where they intersect, and in so doing, we can find those actual values. It might behoove us, I love that word, it might behoove us to adjust our window a little bit. So I'm going to press zoom, and I'm going to do something I don't do much. I'm going to zoom box, which will kind of make it look a little more like this, what I see here. So the lights just went out in this room. I've been sitting still for so long, doing math problems. There we go. And this is going to help me find those points of intersection. Now, those points of intersection, I'll go ahead and tell you, they're going to be crazy, irrational numbers. And I don't need to round them off. I need to be very accurate with those things. So let's be careful. And I'm going to go ahead and kill 2 birds with 1 stone here. Not that I kill birds with rocks, but I'm going to kill 2 birds with 1 stone. When I find that coordinate, I'm going to find the coordinate. I'm not just going to find the x value. All right, got to get up, move around the room, turn the lights back on. I'll be back after I press second and calc and find a point of intersection. First curve, enter. Second curve, enter. Guess, get close to the point. I'm going to get up, I promise. Enter. There. Ah, and there was light. So we are going to use this value for that point, and we'll find the other one for the other point. Now, again, I need to make sure that these are stored in my calculator. So just for future reference, this coordinate right here, I'm going to call it AB. I'm doing that because in a minute I'm going to have to store these values. So I'm going to call this one AB, and we'll call that one CD. Using capital letters because that's what the calculator uses. Right now, my calculator thinks that x is this and y is this. So we're going to store that. And so AB is, let's see, x is going to store as A. And I got 0.159. That's what I'm going to write on my paper. But when I use this, I'm going to use 0.15859, blah, 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 blah. Okay. My current y value was that point of intersection. I'm going to store it as B. Whoops, not like that. B. And it is 2.079. There we go. And we're going to find that point as well. I'm going to need them because I'm going to have to build something here. So C and D, we're going to do those as well. So second, second and intersect. I pressed alpha. So second in calc is what I meant to say. And first curve, enter. Second curve, enter. Guess? Well, when you guess, you need to be close to the point you're looking for. Otherwise, the calculator is just going to work its way back to here. So there, close enough. And we found it. So CD equals 3.146. That looks suspicious. And then 3.573. That is not pi, but it's awfully close to it. Okay, let's store those. Right now, my calculator thinks that x is this. It just reassigned x, and I'm going to call it c. And I have a y value. I'm going to store it as d. There we go. Everything I need is stored right now. And actually, if this was a free response question, then the people that are grading my paper would look at this and they would see, oh, he thinks that A is this, and B is this, and C is this, and I've labeled those points of intersection so they know that I know what those points are. So in the future, as I do this problem, it is totally valid for me to say, oh, I'm going on the x-axis. Technically, I'm going on the line y equals 1, but it is horizontal. I'm going from an x value of A to an x value of C. Totally okay, you can do that. So instead of writing this and this, I'm going to write A and C. It's defined, it's fine. So we're going to rotate outer minus inner, and the outer is this curve, which would be this. But this is shifted in a different way than it's normally defined, okay? So normally I have a y-intercept of 2, right? This technically would be like a y-intercept of -1, and then, because if you plugged in a 0 for, well, anyway. No, actually, whoa, I just said the wrong thing. I was talking about the y-intercept of this, and it has no y-intercept. Does it? No, it has no y-intercept. It does not. It's asymptote. What in the world was I thinking? Okay, woo, wrong. Okay, erase the last 20 seconds of your memory, and let's move on. Basically, everything is shifted up 3, but I sort of lied because now it's just shifted up 1 less than that. Okay, so even though you might say, well, where's your +3 have to do with this curve? I don't see a +3 anywhere. Don't worry about it. Whatever it was, whether it looks like it was up 3 or not, it's no longer up that many. It's up, notice this gap, it's up 1 less. So the first function I'm going to write is this, and I'm going to write a little bit too much here. So natural log, it looks like limit. Let's fix this thing. Natural log of x, I'm struggling to write. Natural log of x over 2 plus 3 minus 1. Okay, now I know you could have been like natural log of x over 2 plus 2. I hear you. You're right. You're not wrong. Why did I put this parenthesis here? I don't know. But I did. There we go. And we're going to square that one. And then minus. Okay, outer minus inner. There's your outer function. Your inner function is this, but it's not this. This one's a little bit easier to see what this 2 does. The 2 is the y-intercept. That's what I was referring to earlier when I made a terrible mistake and I assumed that dot went with that curvy graph, and that's way wrong. Sorry about that. But this line normally has a y-intercept of 2, and it does, but if I'm going to call this my x-axis, and it's not, but if it's my axis of reference, instead of a 2, it would be a 1. So if you want to get all weird and technical and do too much work, you could do this. And then we'll figure that out. So let's go ahead and do that very quickly. We can do that. All those are stored in there. Yep, they're all in there. Everything's good to go. They better be in there, and they better be right because I found those points of intersection from them. And we're going to do pi math 9 from A to C of, okay, this is y1 minus 1, and we'll square that, and then minus, parentheses, y2 minus 1, and we'll square that, and then dx. It takes it a minute, still faster than I could do it. And we have 11.611. There we go. All right, things are about to get a little crazy. We're going to rotate this around the y-axis. Whoa, what? All right, time for the eraser. Erase this line right here. And no longer are we rotating around this line. We are now rotating around this line. Wait a minute. Wait a minute. Okay, we are not rotating around a horizontal axis. We're rotating around a vertical axis. And in so doing, we are going to have a completely different set of thinking skills. And it's not going to go from A to C, x values. It's going to go from B to D, y values. B to D, okay? And we're going to have some function squared minus some other function squared dy, because we're rotating around a vertical axis, not a horizontal axis. Okay, now things get really fun. We're going to switch colors again. If I'm going to rotate this way, then I need to say, oh, well, my outer function is the line. That's great. It is the line, and I'm excited about that. Let's draw the line. Well, let's write the equation of the line. We're not drawing the line. That's the equation of the line. Well, because I'm rotating around a vertical axis, I need y's in here, not x's, right? Okay, so I'm rotating around a horizontal axis here, and I had dx with lots of x's. I need this to be solved for x, so I'll have y's instead. And so x equals, we'll double everything, 2y minus 4. That is my outer function. So furthest from my line, my axis of rotation, is my outer function, which is 2y minus 4. Okay, great. That goes here, and it goes first. Now, do I need to shift things or translate things? No, I don't. This is simply the y-axis. It's not some other line that is also vertical. It's simply the y-axis. So 2y minus 4. Okay, now we have to deal with the inner function. So let's look at it differently. From my axis of rotation, the line is the furthest, the curve is the closest, and we're still doing outer minus inner. So, one more different color here. Y equals natural log of x over 2 and then plus 3. I have to solve this one for x. Let's do it. Y minus 3, and then we double it, and that leaves me with the natural log of x. And then we're going to rearrange a few things. So we're going to have e to this power, so 2y minus 3, and that's equal to x. If I solved this equation for x, this is what I'd get, and it's going to go right here. E to the 2 and then y minus 3. There we go. All right, we're going to do this one by hand. I'm kidding, we're not. And once we do, we will have the answer. We just had to put it in terms of the other variable. This is going to get a little bit tricky, and I'm about to sneeze. Twice. All right, we're going from B to D. Bless me. 2y minus 4 squared. That was the easy one. And then we got to get this monstrosity here. Now, technically, you want to go crazy on us? Let's do it. Let's do it. I'm not going to write it, but I am going to type it. I have a e to a power, and because there are no other constants that I'm adding or subtracting over here, I can just take this 2 and multiply it with this exponent, which really just gives me a 4 there. Totally doable. Power to a power, just multiply your powers. So I have e to the 4, and then y minus 3. And that is squared. That's where the 4 came from. All parentheses accounted for. Yes. All right, these parentheses here, here's the right one, and here's the left one. I technically don't need them, but I'm going to leave them. I like to over parenthesize. Makes life interesting. And answer. We got it. 8.550.